Good morning, students. As we have discussed about the concept of sets, it is a well-defined collection of objects and its presentation like roster form or tabular form, and the symbol epsilon, which means belongs to. Okay, so we are going to solve the exercise 1.1 problem, right? So look at the question number first. And the first part, the collection of all the months of a year beginning with the letter J. Collection of all the months beginning with the letter J. So we know that the letter J. So how many months are starting with J? January, then February, March, April, May. Next one is June. Next is July, August, September, October, November, and December. So how many months we got, which is starting with J? So these are January, June, and July. So what do you say? Is it well defined or not? Can any another month come or not? No. So with the letter J, only these 3 months coming in a year. So definitely this is a well defined collection. Okay, so the meaning was well defined means no other month should be adjusted in this collection. So this set A is well defined, so it is a set. Okay, now look at the second part. The collection of 10 most talented writers of India. The second part, most talented. So I would like to say you there are some collections, okay, like most talented teachers, most talented students, most talented doctors, most talented. So these words are vague terms. Vague terms means these terms have no certain parameter or certain criteria to decide exactly who is most intelligent or who is not. So these collections should not belong to well defined collections. These collections are not well defined collections. So rather, wherever you find most talented, some words I am going to write intelligent. For example, find a collection of the intelligent students of class 11th, right? So the word intelligent has no definition at all. Okay, there is no criteria to define who is intelligent, who is not intelligent in certain areas, in terms of discipline, in terms of a good score, and it. So these terms cannot be related as what well defined collection. These cannot be taken into well defined. So most talented, intelligent, and the word good, the collection of good students, and it. So all are good students. So there is no criteria for good, that who are scoring maths good marks, so they are good student. If the student not scoring good marks in Hindi, so that is not good. So these words should not have certain parameter. So we will consider these words most talented, intelligent, good. Okay, in fact these are what adjectives. So these adjectives should not be taken into the consideration of well defined collection. Alright, so the second part is what you will say, it is not well defined, so it is not a set. So there are some more words like most dangerous. One more word is there, collection of most dangerous animal. So there are many animals, and if I talk about snake charmer, and it snake charmer, so he plays with snakes. So we may be panic if we find somewhere a snake coming suddenly in your class. So everybody will be going here up and down. Even nobody will be thinking about me. Sir, you be there on the same place. Let I face a snake. And it. So, but on the other hand, if we call any snake, he will be playing with that, and it just wrapping around the neck or keeping in that bag or something, and it. So most dangerous animal, right? So there are many people who loves with tiger, and it they are having tigers at their home, and many other animals. Okay, so we cannot consider the collection of most dangerous animals or any insect as a collection of well-defined collections. Alright, so these adjectives wherever you find, we are not going to have the collections well-defined, so we will not take as consideration into our set. So there are 8-9 parts. In fact, some of the parts I have discussed, so try to solve the remaining parts. Now let's discuss the question number 2. There is a set given A equals to 1, 2, 3, 4, 5 and 6, right? 6 elements are given and we have to use the appropriate symbol. Recall, the symbol means belongs to. It is which type of symbol? It has been taken from Greek language. Okay, it is a Greek word taken from Greek language. Epsilon, we read as epsilon, means constant and means belongs to. Okay, so if we write this epsilon cross, it means does not belong to. Okay, so make sure we use for an element as well as the set, that an element belonging to a set or not. So the first part 5 and A. In this question, first part 5 is given, fill in the blanks A. So we have to check this 5 is the element of set A or not. Check. Yeah, 5 is coming there. So we will use this symbol. It means 5 belongs to A. That is 5 is the element of A. Now next 8. Next part is 8. Then 8. What will come? Answer. Is 8 coming? No, 8 not coming. So we will do this one. That is 8 does not belong to A. Same as 4. Next part 4. So 4 belongs to A. Clearly 4 is coming in this set, existing in this set. Okay. So this is all about question number 2. Now let us see the next problem number 3. Write the following sets in the roster form. As we studied in previous lecture, roster form. So just recall till I write the question. X is such that X is an integer. It is an integer. Also, X is less than 7 and greater than minus 3. So in roster form, we write all the elements and put comma, right, to separate them. So X is such that X is an integer greater than minus 3. So write the integers greater than minus 3, that is minus 2 in just next integer. Then minus 1. 0 is also an integer. So we'll write 0, 1, 2, 3, 4, 5, 6. Alright. So less than 6. Sorry, less than 7. 6 is the last integer. So this is the representation in roster form. Second part, B equals to X is such that X is a natural number less than 6. So write the natural number less than 6. 1, 2, 3, 4 and 5. This is the second part in roster form. Okay. Same as third part. X is such that X is a 2-digit natural number such that sum of digits is 8. Sum of digits is 8. So then if we write 1, so we have to write 7 because 1 plus 7 is 8. Similarly, its reciprocal also. This is also a natural number. Okay, 2 digit. Next 2, then we have to write 6. 26, 2, 6, 8. So it reverse of the digits. 6 2 also gives 8. Next 35. 3 5 8. So reverse the digit. That is 5 or 3. Next number after 5 6 will come. That is 6 2 already taken. Okay. So these are the only 2-digit numbers whose sum is what? 8. Next I'm taking fifth part. E. This is 2-digit natural number. Yeah, C. Now the fifth part, E equals to the set of all letters in the word trigonometry. Okay. So X is such that X is what? Is of all letters of the word T R I G O N O M E T R Y, right? Trigonometry. So we have to write in the raster form. So in raster form, we start writing these letters T. Make sure the letters should not be repeated. As we studied, this is one of the characteristics that we can write these letters in any order and ensuring that no letter should be repeated more than once. So T has come, then R, next I, and next G, O, then N. This O will not be taken because we have written. So O is coming 2 times, so we will write only 1 time. Then next is M, next E. Okay, next T is coming, so T has written, R already written, and then Y left. So Y. So make sure each and every letter should be written 1 time. So this is what the representation of the given set into roster form. Okay. Same as the next word is given in 6th part. Now question number 4. Look at the part first. Write the following sets in set builder form. So let the set A is given as 3, 6, 9, 12. Set builder form is somewhere little, we have to think. It's a logical question that we have to think about its properties so that only these numbers should be coming in that property. Okay, so we have to describe that or design that property. So first of all, we start writing X as X for all the questions. Now the second point, we have to think this is what special type of collection of numbers. See 3, 6, 9, 12. Just think. It is showing, it is coming in a definite sequence and it is showing of different distinct pattern of the numbers. So clearly these are what X is X is a multiple of 3. Check, all these are multiple of 3. 3, 6, 9, 12. And but there are many multiples. So this last one is what? 12. So we will restrict it. This X is a multiple of 3 where how many we have to take? Where we have to consider only first 4 multiples. Right? So you can write in short that X is such that X is a first 4 multiples of 3. Right? Combining these two things because these are relevant to this. So the finally the answer is X is such that X is first 4 multiple of 3. Or you can also write the solution of this question. Let X equals to mathematically. This is what we have written in statement form. Now we can also write in mathematical form x is such that x equals to 3n, where this small n belongs to what? The natural number, and natural number is what? There is a restriction less than equals to, this is the 1, 2, 3, 4 multiples. So n is less than equals to 4. So we can also write in this form. So finally we have to write, this is the one of the answer, second answer, when you can find the third one, so that only these numbers should come. See, if you put n equals to what? Natural number starting from generally 1. So 1, 2, 3 and 4. So if you put here 1, 2, 3, 4, so you'll be getting these 4 numbers, right? So this can also be the answer of this question. Now let us solve one more part. Second, 2, 4, 8. 2, 4, 8, 16 and 32. Alright. So now think about, the number has been written in what kind of pattern. That pattern has to be recognized. That is mathematical reasoning or aptitude we have to apply. So see, this is coming in which pattern? 2, then square, then 8, then 16, then 32. So make sure these numbers are coming as an exponent of 2. See, you cannot say these are the multiples of 2, because if I say multiples of 2, then there may be some more multiples also existing, like 2, 4, then 6 can also be there. If I write the solution is what? These are the multiples of 2. So there may be existing some other numbers, right? Like 6 is there, 10 is there, 12 is missing, right? So all these numbers should also come. So we have to write straight away. See what I am writing? 2 raised to the power n. Okay, 2 raised to the power n, where n belongs to the natural number, and this, the value of n will be what? Less than equals to 1, 2, 3, 4, 5. Check 5. Let us verify. If I put here n equals to 1, then we'll get 2. If I put n equals to 2, 2 square gives 4. If I put 3, then 8. 2 to the power 4, 16. 2 to the power 5, 32. Isn't it? So you have to be logical for such parts. So you cannot write multiple of 2, right? Or table of 4 or something else. This is what straight away exponent of 2. So same as 2 more parts are there, and question number 5 and 6. So try to solve question number 5 and 6 also. I think you can solve if you have got these concepts. Further, if you have query, you will ask it to me. Thank you very much.